In this video, we're going to look at simple parabolas where the b is still 0 and the a is never 0, because if a is 0, then we don't have a quadratic equation anymore. We have simple parabolas. In this case, I've just used x squared, the mother graph, and I've added 1 and I've subtracted 2. So first of all, let us calculate the values in a table. If we take -1 and we square it, we get +1. If we take 0 and we square it, we get 0. If I take 1 and I square it, I get 1. So if I now take this +1 and I add it to the previous one there, I get 2 and 1 and 2. And if I take the -2, subtract that from the initial one there, I'll get 1 minus 2, which is -1, -2, and 1 minus 2 gives me -1. So this is our table. If we look at this graph, then we see here that y is equal to x squared is our mother graph, the green one. And now the red graph is y equal to x squared plus 1. And the reason for that is that we've taken a value here and we've added 1, so the distance here is 1. We've taken a value here, we've added 1, and the distance is 1, and we've taken a value there, we added 1. So in this case, BD is equal to 1, OG is equal to 1, and AC is equal to 1. And I've just taken the y values and added 1 unit to it. That's all. Again, we have our y equal to x squared, our mother graph, the green graph. And here we will now have y equal to x squared minus 2. So if we look at the distance here, it's 1 unit, another 1 unit, so we have a distance of 2. Here we have a distance of 2, and there we will also have a distance of 2. So we have AE equal to 2, we have OH equal to 2, and we have BF equal to 2. And it doesn't matter where you take an x value. If you go vertically upwards, the distance between the graphs will be exactly 2 units. The top part there is again, I've just left that graph there, y equal to x squared plus 1. So this is how easy the vertical shifts are. So there's an exercise that you can do that has a little bit more variation than this one, where I've also changed the function, the original function, to 2x squared, etc. You can try that on your own. We've seen what happens with positive a and vertical shifts, so let us look at simple parabolas where I've taken f of x equal to minus x squared and just added some y values to that. Let us fill in the table first. So I have minus and in brackets -1 squared, so the answer is still -1. Minus 0 squared, which is still 0, and in that case minus times 1 squared, which is also negative. If I now take this value again and I add it to there, I will get 0, I'll get 1 and 0. And if I take this -2 and I add it to the original one, I will get -1 minus 2, that gives me -3. 0 minus 2 gives me -2, and -1 minus 2 gives me also -3. If we look at this graph, we see that this is the graph of y equal to minus x squared, and this will now be y equal to minus x squared plus 1. We look at this distance here, we see this is OG, that distance is equal to 1. If we look at this distance, BD, that is also equal to 1. And if you look at this distance, AC, that is also equal to 1. And although it looks on small scale locally, it looks as if the functions will eventually reach each other. It will never touch each other, even at infinity, or even intersect each other. Again, this is our y equal to minus x squared. This was our function y equal to minus x squared plus 1. And this is now y equal to minus x squared minus 2. If you look at the distance there, that is OH, that will be 2. If I look at AE, I will get a distance of 2, and if I look at BF, I will also get a distance of 2. Simple shifting down. And the number that we use to, or how many units we shift, is here, because we're changing the y values. Every y value is added by, there's 1 added to the y value. In this case, every y value is added or subtracted to. That's how simple it is. Please just look at this OH here. I said it is 2, but I've written 0, so please just change it to that.